For countless generations, a brilliant red star has captured the attention of people across the world. Hanging above the horizon within the constellation Orion, this crimson giant has stood out among the countless lights scattered across the night sky. Its distinct color and changing brightness made it impossible to ignore, inspiring stories, legends, and observations long before the invention of modern astronomy. Ancient skywatchers noticed that this star did not behave exactly like others. While many stars appeared steady and predictable, this one seemed to brighten and fade over time. The changes were subtle, often unfolding slowly across months or years, yet they were noticeable enough that careful observers recorded them. Without telescopes or scientific instruments, they could not understand the cause, but they recognized that this star possessed an unusual character. Today, astronomers know that this remarkable object is one of the largest stars visible to the naked eye. Located hundreds of light-years from Earth, it belongs to a rare class of stars known as red supergiants. Although its surface is cooler than that of our Sun, its enormous size allows it to shine with extraordinary brightness. The scale of this star is difficult to imagine. If it were placed at the center of our solar system, its outer atmosphere would extend far beyond the orbit of Mars and could even reach the region occupied by Jupiter. The planets closest to the Sun would disappear inside its vast envelope of hot gas. Unlike our relatively stable Sun, this giant star exists in a far more turbulent state. Its surface is constantly changing. Massive currents of hot plasma rise from deep within while cooler material sinks downward. These gigantic circulation patterns create bright and dark regions that shift across the star over time. Some of these convective regions are so immense that entire planetary systems could fit inside them. The star's surface is therefore not smooth or uniform but a constantly evolving landscape shaped by powerful internal forces. Beyond the visible surface lies an enormous atmosphere extending millions of kilometers into space. Powerful stellar winds continuously push material away from the star. Gas and dust flow outward, forming vast clouds that surround the giant like a cosmic veil. This loss of material is not a minor process. The star is gradually shedding portions of itself into interstellar space. Carbon, oxygen, nitrogen, and other elements created deep within its interior are carried outward by these stellar winds. Over time, this matter becomes part of the galaxy itself. The significance of this process extends far beyond the star. The atoms released into space may one day become part of new stars, planets, oceans, and perhaps even living organisms. The elements essential to life are forged inside stars and later returned to the cosmos through events like these. Despite its beauty, however, this red giant exists in a delicate balance. Gravity constantly pulls inward, attempting to compress the star. At the same time, energy generated by nuclear fusion pushes outward, resisting collapse. For millions of years these opposing forces have remained in equilibrium. But such balance cannot last forever. As massive stars age, their internal structure becomes increasingly complex. The fuel that powers them gradually changes, and maintaining stability becomes more difficult. The giant continues to survive, yet signs of growing instability become increasingly apparent. Astronomers have observed fluctuations in brightness, changes in temperature, and enormous eruptions of gas. Each observation reveals a star undergoing dramatic transformations as it approaches the final stages of its life. One of the most surprising events occurred when the star suddenly dimmed far more than expected. Its brightness dropped significantly, attracting worldwide attention and sparking intense scientific debate. Observatories around the globe turned their instruments toward Orion to investigate what was happening. Some wondered whether the long-anticipated death of the giant had finally begun. Others suspected a different explanation. As new observations arrived, researchers discovered that the star itself had not dramatically weakened. Instead, it had expelled a huge cloud of gas and dust that temporarily blocked part of its light. The event demonstrated just how active and unpredictable this stellar giant truly is. Rather than quietly fading away, it continues to surprise astronomers with behavior that challenges existing theories and raises new questions about how massive stars evolve. Deep within the core of this enormous red giant, nuclear fusion continues to generate energy. For most of a star's life, hydrogen serves as the primary fuel. As that supply diminishes, increasingly heavier elements begin to form through successive stages of fusion. Helium is transformed into carbon. Carbon contributes to the creation of even heavier elements. Layer by layer, the star develops a complex internal structure resembling a cosmic furnace operating at unimaginable temperatures and pressures. Yet this process cannot continue indefinitely. Eventually, the core will begin accumulating iron. Unlike earlier fusion reactions, iron does not release energy when fused. Instead, it requires energy to proceed. Once iron becomes dominant, the star loses its ability to generate enough outward pressure to resist gravity. At that moment, the balance maintaining the star's existence will break. The collapse will occur with astonishing speed. A core that took millions of years to evolve may fail within seconds. Gravity will compress the central region while surrounding layers rush inward. The resulting forces will trigger one of the most powerful events in the universe. A colossal supernova explosion will follow. For a brief period, the dying star may shine with a brilliance rivaling billions of ordinary stars. The explosion could become one of the brightest objects visible from Earth, transforming a familiar point of light into an extraordinary celestial beacon. Although such an event would be spectacular, it would not threaten our planet. The star lies far enough away that its explosion would be observed as a magnificent astronomical display rather than a dangerous catastrophe. The greatest uncertainty is not whether the explosion will happen, but when. Astronomers know that the star is approaching the final stages of its evolution, yet predicting the exact timing remains impossible. It could occur thousands of years from now. It could happen much sooner. Current observations cannot provide a precise answer. An even more fascinating possibility emerges when considering the immense distances involved. Because light requires centuries to travel from the star to Earth, any event occurring there is not seen immediately. Every observation represents the past rather than the present. In theory, the explosion may have already happened, with its light still traveling through space toward our planet. If that is the case, humanity simply has not received the message yet. Until the final moment arrives, the star remains a laboratory for understanding stellar evolution. Researchers continue monitoring its brightness, temperature, motion, and surrounding dust clouds with increasingly sophisticated instruments. Each new observation reveals additional complexity. Massive eruptions reshape its atmosphere. Dust clouds appear and disperse. Internal pulsations ripple outward through its layers. The star behaves as a dynamic system undergoing constant change rather than as a fixed object in the sky. When the supernova eventually occurs, it will mark not merely an ending but a transformation. The explosion will scatter elements forged over millions of years into interstellar space. Those materials will mix with cosmic clouds and contribute to future generations of stars and planets. In that sense, the star's final act will also be a beginning. The matter released during its death may someday become part of worlds that do not yet exist. Future solar systems could emerge from the remnants of this ancient giant, continuing a cycle that has shaped the universe for billions of years. For now, the red supergiant remains visible above Orion, shining across the darkness as a reminder that the cosmos is always changing. Even the most familiar stars are not permanent. They evolve, transform, and ultimately return their material to the universe, ensuring that creation and destruction remain forever linked in the ongoing story of the cosmos.